Okay, the first thing we're going to do is we're going to find the distance formula. And so we are looking at the distance between -3, 7 and -8, 14. And the distance formula is d equals the square root of x squared minus x1 plus y, it's x sub 2 minus x1 squared plus y sub 2 minus y1 squared. And x sub 1 and x sub 2, the x sub 1, y sub 1, x sub 2, y sub 2, those are just points. Like, you don't have to worry about that fancy stuff. It's just points. So you're subtracting x values from y values. Man, I am not saying anything right. You're subtracting x values and you're squaring it, and then you are subtracting y values and squaring it. So don't get overly confused with the subs. Just be sure that both of these are x values right here, and that both of these are y values. That's super, super important. Okay? So I'm going to start with this point. It doesn't matter which point you start with as long as you've got your x values. And that's what you're using is both x values. So I'm going to say -8 minus -3. -8 minus -3. And then I'm going to square that. And then I've got 14 minus 7. And I am going to square that. Okay? So we've got a double negative right here. So I'm going to make this +3. -8 plus +3 is -5. 14 minus 7 is 7. Okay. Then we're squaring both. -5 squared is 25. 7 squared is 49. We add those two values together and we get the square root of 74. Now the quiz actually said answer to an approximation of 3 decimal spaces, and I'm actually more interested in the square root of 74. So the square root of 74 is a exact answer. And in general, I like to keep things exact. Any questions? I won't count off either way, because it very clearly said 3 decimal spaces. And so, but either way, I won't count off. The 3 decimal spaces is an approximation, and I don't think we always think of it as approximation, because you do have to round, so that's an approximation to where the square root of 74 is exact. Okay? Okay, are we ready? Okay. Our next one is the midpoint. Again, it doesn't really matter which point you start with, as long as you start with that same point for both the x's and the y's. I'm going to start with this point right here. So I've got -2 plus 4, and I will give you all of the formulas, because this particular formula has a plus in it, and so many of the others have minus. So that's a place that sometimes students make mistakes, but I will give you the formulas. Then we have -6 plus -4. And all of that is over 2. -2 plus 4 is +2. So we get 2 over 2, which becomes 1. So our x coordinate is going to be 1. -6 plus -4 is -10. Okay, and so our y coordinate is -5. So the midpoint of this problem is 1, -5. Is that good? Okay. Number 3. Excuse me. I am very sorry about that. Okay. This is a circle, and we are identifying the center and the radius of a circle. The thing that sometimes is confusing for students about this right here is in the original formula, you have subtraction. So your H and your K are going to be the opposite of what is up here in parentheses. And that confuses lots and lots of students. So I'm going to rewrite this just so you can see it. Now the blue, I am writing the actual formula. And the red is the coordinate, okay? So the x plus 7 breaks down to x minus negative 7. And that's squared. And so the h value there is negative 7. Okay, and the same is true over here. Now, you don't have to rewrite this, but I typically rewrite it a couple of times just so you can see it. Okay, and what's the square root of 81? Good. And so that's 9 and squared. So the red is what we're pulling out. The red is what we're pulling out. So the center of my circle, the center is going to be negative 7, negative 6, and the radius of my circle is positive 9. Okay, so when you're doing this one, you're taking the square root of whatever number's right here, and you are doing the opposite of what you see in your parentheses. You're doing the opposite there. Okay, students typically did okay on 1, 2, and 3. Typically did pretty well on 1, 2, and 3. When we get to number 4, students often are like, I don't even know where to start. And I saw all sorts of things on your quiz when we started looking at number 4. I had so many people trying to put this into a line. They were trying to solve for y. I had lots and lots of people trying to solve for y. And what did I say? If any of you guys came up to my desk, what did I say to do? Yes, that's exactly what I said. I said to put it in Desmos, okay? So that you could get a visual of what's happening. So when you put it in Desmos, and Desmos made it much prettier than I'm going to be able to make it. Oh, actually, maybe not. I forgot about all the great tools I have. Okay. Well, not really sure what just happened there. So when I put it in Desmos, you should have gotten, this is hard. Okay, that's as close as we're going to get. Okay, so when you put it in Desmos, you should have seen a circle, and that circle was centered around the origin. That's where the circle was, centered around the origin. Now, the radius of this circle was 3, because we took the square root of 9. Now, we weren't asked to find the center. We weren't asked to find the radius. But when you graphed it, you realized what shape it was, and you realized what was happening. You know, like, okay, so this is actually symmetrical to the x-axis because I can fold it on top. It's actually symmetrical to the y-axis, and it's symmetrical to the origin. And so if you had not graphed it, if you had not looked at what that shape was going to be like, you might have been scared to say it was symmetrical to all 3. But it is symmetrical to all 3. Now, the question says to determine algebraically why. And you know, so you kind of visually look at it, but now we've got to determine algebraically why. So we start with our x-axis. When we're doing the x-axis, to see if something's symmetrical to the x-axis, we replace y with negative y. Okay? We replace y with negative y. So I'm going to have x squared is going to stay the same. And for y, I'm going to put in negative y, but I'm still going to square it. So I'm just pulling out the y, and I put the negative y in. And I have to see if I get that same answer. So I still have x squared. Okay, negative 1 and the y are being squared. So what's negative 1 squared? Good, it's positive 1. Okay, so that's how I end up with y squared. And that is exactly what I started with. So this is symmetrical to the x-axis, which we already knew because we looked at it. But so what I've done is I've just shown algebraically that it's symmetrical to the x-axis. So yes, it is symmetrical to the x-axis. For y, we're going to do something very similar for the y-axis. We are going to replace x with negative x. Okay, we're going to replace x with negative x. So I've got negative x squared. So I've just taken out the x and I've put the negative x in there. Then I have y squared. And then I have 9. So negative x squared is going to be positive x squared. Okay? And that gives us back the original problem. So this is symmetrical to the y-axis. Okay? The origin, to determine if something's symmetrical to the origin, we replace both. Replace y with negative y and x with negative x. Okay? So now I'm going to have negative x squared and negative y squared. And when I square each of those negatives, I get x squared plus y squared equals 9. And so it is symmetrical to all three. And the visual is super helpful for you to see why. Because I think a lot of students are like, well, how can it be symmetrical to all three? Okay? And the one comment that I just want to make about that, the problem did say to determine algebraically. And so that's why you had to show how that happened there. Now, I also want to talk, because our next problem has to do with an odd and even function. If a function is symmetrical to the origin, it is an odd function. If it is symmetrical to the y-axis, it is an even function. Okay? If a function is symmetrical to the axis, it's not a function. Okay? So a circle is actually not a function. It's a transcendental. No, it's not a transcendental. It's another thing. But it's not a function. You would have to you'd have to say no, it doesn't pass the vertical line test. So our next problem is asking us if a function is even or odd or neither. Even, odd, or neither. And so we're going to move on to that. Is it okay if I move to that one? Okay. So we are determining if a function is even or odd or neither. Now, if something is even, we replace x with negative x, because we're testing to see if it's symmetrical to the y-axis. If something is odd, we test to see if it's symmetrical to the origin, so we replace x with negative x and y with negative y. Now, the function that we are using on this is 6x to the 5th minus 9x to the 3rd. Now, if you remember this example in class, I said all seniors at the University of Montevallo are students at the University of Montevallo. Okay, and we decided that that was true, that all seniors at the University of Montevallo are students at the University of Montevallo. But the reverse of that is not true. When I said all students at University of Montevallo are seniors, that is not true. So when I look at this, we discussed all even functions have an even exponent. And we're talking about their highest exponent. We're talking about their highest exponent. So all even functions have an even exponent. Now, we aren't saying that everything with an even exponent is an even function. What we're saying is that for something to even be considered an even function, it first has to have an even exponent. Okay? Now, for an odd function, all odd functions have an odd exponent, and their highest. We're talking about their highest exponent. So all odd functions have an odd exponent. And again, we're not saying that everything with an odd exponent is an odd function. We're just saying to start with, for something to even be considered an odd function, its highest exponent must be odd. So if we look at this right here, so we're testing for even and odd. We're not even testing to see if it's symmetric to the x-axis, because that's not a function. We're testing 6x to the fifth minus 9x to the third. What is its highest exponent? That is its coefficient. 5, correct. Okay, so this number and this number are they're called coefficients. Exponents are what your variable's being raised to. That was good, Sabrina. So 5 is my highest exponent. Is that odd or even? The number 5. Is the number 5 odd or even? It's fine. I totally get it. Okay? So we do not even need to test for even. We don't even have to test for even because my highest exponent is odd. So that saves me some time. Okay? So I only have to test to see if this is an odd function. I already know it's not an even function because it doesn't have an even exponent. Okay, now the f of x. What do I take out and put in place of the f of x? Yes, f of x and y are exactly the same thing. F of x and y are the same thing. So I'm going to have y equals 6x to the fifth minus 9x to the third. Okay? Now, to test if it's odd, I'm going to replace x with negative x and y with negative y. So I'm going to have negative y equals 6 times negative x minus 9 times negative x to the third. Now, I want you to notice right here, I am inside the parentheses for this negative x. So the negative and the x is being raised to the fifth power. So and it would be just like if I was putting a negative 2 in there. Okay, we're replacing x with the variable negative x. When I raise a negative number, negative 1x, so that negative 1, when it's raised to the fifth power, do I get a positive 1 or a negative 1? So when I raise it to an even power, I get a positive. So when I raise it to an odd power, I'm always going to get an odd. So negative 1 times negative 1 times negative 1 times negative 1 times negative 1. Okay? So here I get a positive. Here I get a positive. And here I have a negative. So 1 times negative 1 is negative. Okay? So if I've got a negative number and I raise it to an odd exponent, I'm going to keep that negative. Okay? So this is negative y equals 6 times negative 1 times x to the 5th. Okay? What's going to happen with that negative x to the 3rd power? Is it going to go to positive or is it going to stay negative? Excellent. It's going to stay negative. So then I'm going to have negative 9 times negative 1 and x to the 3rd. Okay? And I should have probably put this in parentheses. So then I have negative 6x to the 5th, positive 9x to the 3rd. So I just want to make sure you see this is minus 9 and that's negative 1. That's how I get that positive there. Okay? And my last step is I divide everything by negative 1. Okay? So I have y equals positive 6x to the 5th minus 9x to the 3rd. Does this match this, other than the y? Y and f of x are interchangeable. Are those the same? Yes. So that means this is an odd function. So my final answer to this problem right here is this is an odd function. And we have tested that algebraically. Yes. Okay. For number 4, the final answer is all yes. You are correct. Okay? Okay. Number 6. This one caused some problems. This one made students a little bit crazy. And that's okay. We can work through it. We can work through it. So it's asking me lots of different things. It says find the domain and the range of the function. Determine the intervals on which the function is increasing, decreasing, and constant. So we're really doing, well, we're doing 5 different things, but we can think of them in 2 different parts. So the first part that we're going to think of is we are going to think about our domain and our range. We're going to look at that part first. Domain and our range. Okay? Now, our domain is all of our x values. All of our x values. Okay? So, I'm going to start right here because that is my furthest x value to the left. And I'm going to go, now I've got an open arrow, or I've got an open dot right here, but am I covered down here on my x? Yes. And so I keep going. And then I do stop right here because there's a gap. Do you see this gap between these two? So my domain has stopped there. So I don't have any x values in between that. So it has stopped. It picks up again at 1, and it goes all the way to 5. Okay? So that is my domain. So I start here, okay? And do I have an open dot or a closed dot at negative 5? I have a closed dot. So that means that negative 5 is included. Now, I go all the way to 0. Okay, now I've got 2 different line segments here, but I'm still going all the way to 0. Now at 0, do I have an open dot or a closed dot? I have closed, so 0 is included. Now, some students will say, but Alicia, that dot's at negative 1. Why are you putting 0 when that dot's at negative 1? You need to remember that this point right here that I'm pointing at is 0, negative 1. That's the point. In domain, I'm always talking about my x value. That is why I go all the way to the 0, because I'm talking about my x value. Okay? Now, there's nothing in between 0 and 1 on the x-axis. There's nothing. So I pick up again right here, and that is my y value of positive 1. That's my x value. I'm sorry. I said y. That's my x value. And I go all the way to this x value. And is there an open or closed dot there? Good. Okay. So that is my domain. Okay. My domain is x values. You pay attention to the x coordinate. Okay, now I'm going to erase just the stuff on the graph. Is that okay? Just the stuff on the graph? Okay. Okay. Now, I am going to look at my range. I'm going to look at my range. Now, this is my lowest dot down here. Okay? That's as far as I go. And I'm going to focus on this dot right here. The ordered pair for that is -2, -5. What is the y value of that ordered pair? -5. Okay? So that's what we focus on here. So I start here and I go all the way up here. Now again, my ordered pair right here is 0, -1. When I'm doing range, I'm focusing on my y value. So the parts that I'm interested in are this -5 and this -1. That's what I'm interested in. Okay? Then I'm back up here, and I got a whole bunch of stuff happening right here. And then I go up to 3. And I am only interested in those y values. So, for my range, I start at my lowest number, which is -5. I go up to my y value. I go to my y value, which is -1. Okay, and then I focus on this one again. I'm going to write it right here just so we're clear. And that's 1 to 3. Okay? So that's the first part of the equation, or the first part of the problem when it's asking for domain and range. Students typically do okay with domain. They struggle a little bit more with range because they forget. They get so used to everything being x, 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 x. For range, you're focusing on those y values. And so sometimes students make some mistakes with that. My advice when you're doing that is to write down the ordered pair. When you physically write down the ordered pair, a lot of times it's easier to identify what that y is in that situation. Okay? Now I need to erase this so we can go to increasing, decreasing, and constant. Is that okay? I can erase? Okay. Okay. So now we're going to do increasing, and that means we have a positive slope. We are making money. Okay? It's a good thing. Then we're going to do decreasing. Okay? Increasing, decreasing, and constant. Okay, so think about slopes. Think about slopes there. Okay, so for increasing, we are looking at any time my graph is going up. And those are the two spots right there that my graph is going up. Okay, now again, for increasing, decreasing, and constant, we're only worried about my x values. Okay, we're worried about where on the graph are my x values showing an increasing in the graph. So I'm looking at these x values right here. That's what I'm looking at for increasing. If you write the points down, so this is -2, -5, and this point is 0, -1, You are less likely to make a mistake here because you're able to identify those x values. So for increasing, I have -2 to -5. And then I also have this area right here. Okay? And I can write down 3, 1, and 5, 3. Okay? So my increasing again goes from 3 to 5. Okay? Now, for increasing and decreasing and constant, you always use parentheses. You always use parentheses. Okay? Okay, so if you look right here, and we kind of got lots of different things right here. This is my x value for that point. Yes. My guess is you were looking at this 3 over here, and you're like, Alicia, that's the y value. It also is the x value on that first point. And then you're looking at this 5 right here.
And what about the -2, -5?
Okay, that is this point right here. And that should be 0. That's me making a mistake. Sorry, guys.
That makes more sense.
Thank you. I'm glad it makes more sense. Sometimes by this time of the day, I'm so tired, especially on my Tuesdays and Thursdays. I apologize. And I even have the answers in front of me. And so it is -2 to 0. Okay. Now decreasing, we just have this one area right here for decreasing. Okay, let me make it a little darker. So that is just this part of your x values. So I've got 1, 3, and then we've already got this written down as 3, 1. But I'm only paying attention to my x values. So my interval for decreasing is 1, 3. Okay. And this is my constant right here. And that goes from -5 to -2. There's one similar to this on your project. And one of the things when I get questions about, and your project is a long way away, is I always say, write down the ordered pairs, write down the ordered pairs. And then students can pay attention to the x value and the y value. So I think that's super important. Okay, can I go to the next screen? Yes. Do you mean the
like the rest of the problems?
Yes.
Okay.
I'll post it on campus. Hopefully not too long after this.
Okay.
Yeah. Oh no, you're fine. You're fine. Okay. Number 7. Okay, this is number 7. And the directions for number 7 are determine the equation of the line parallel and perpendicular to the given line that goes through the given point. Okay, so when we think about what this looks like, we have an original line, then we have a line parallel to that original line, and then we have a line perpendicular to that. Okay? And the point that the two new lines go through is 6, 7. That's the point that the two new lines go through. Okay? So, I like to write it to where I write it like this. I've got
I have that
Okay.
So what could I do?
let's talk about that by email. Okay, let's talk about that by email.
Thank you.
And I think actually the point is 8.7. Okay, so the point's 8.7 that we're supposed to go through. Yes, 8.7. So what we do here is we've got to deal with the original line. Then we've got to deal with the parallel line. Then we've got to deal with the perpendicular line. So we're dealing with 3 separate lines. The only thing we care about with my original line is the slope. Okay, so I've got negative 3x minus 8y equals negative 74. So I'm just going to solve this for y. That's the only thing I care about. So I'm going to add 3x to both sides. So I get negative 8y equals positive 3x minus 74. And then I divide by negative 8. Okay, so I end up with y equals negative 3 over negative 8 oh, it's positive 3. Sorry. I was like, I know I'm making a mistake here. Where is it? Positive 3 over negative 8x plus 74 over 8. Now that 74 over 8 simplifies to 37 over 4. But it really doesn't matter because the only thing that I need is the slope. I don't need anything else from this original line. I only need the slope. So my parallel line is going to have the same slope as my original line. So I am going to have a slope of negative 3/8, and it's going to go through the point 8.7. Okay? So I've got y minus 7. That's the formula we're going to use is point slope. It's y minus y sub 1 equals slope times x minus x sub 1. And I will give you that formula. So I've got y minus 7 equals my slope times x minus 8. Okay? So I distribute my negative 3/8. Okay. Now here I've got negative 3 times negative 8. So that's going to give me a positive. 3 times 8 is 24. And then 24 divided by 8 is what? 3. Good. Okay. Now I add 7 to both sides. So I've got y equals negative 3/8 x plus 10. Okay, and that is my line that's parallel. Now, students typically do okay with a parallel line. They get a little bit stuck with the perpendicular line. The difference between a parallel line and a perpendicular line is your slope has an opposite sign. So since this is negative, my perpendicular line is going to be positive. And instead of 3/8, I have 8 over 3. It is the negative reciprocal. The negative reciprocal. So opposite sign, and you flip your fraction. Then I use my point slope form again. So I have my y minus 7 equals 8 over 3 times x minus 8. This one does not come out as pretty. So I get y minus 7 equals 8 over 3x minus 64 over 3. Okay, so definitely a little bit icky. Now I'm going to add 7 to both sides. So what I have, I'm going to do this in a different color. I have negative 64 over 3 plus 7 over 1. Now, I want to change that 7 over 1 to something over 3. Okay? So 1 goes into 3 3 times. What's 7 times 3? Excellent. 21. The negative 64 plus 21, is it negative 43? Yes. Okay, so I've got 8 over 3x minus 43 over 3. Okay, so I have my original line, I have a parallel line, and then I have a perpendicular line. Okay? And one of the things to remember is that the only thing you care about from your original line is your slope. And then you're going to use the point and the slope from the other information. Okay. The domain of this one, this is one of those things where you don't want your denominator to equal 0. So we have x squared plus 2x minus 15 cannot be 0. Okay. I go ahead and factor this. Factoring is going to be something we do a lot of. I need two numbers that multiply together to give me negative 15. Added together give me positive 2. So that's going to be positive 5 and negative 3. So x plus 5 can't be 0. And x minus 3 can't be 0. So x cannot be negative 5 and x cannot be 3. Now, at this point, I would encourage you to draw a number line. Okay? Here is positive 3, and here is negative 5. Okay? All of this is part of my domain. All of this is part of my domain, and all of this is part of my domain. Lots of people forget this middle part right here. Lots and lots of people forget that. So I start at negative infinity, and I go to negative 5, and then I put a union. Now I've got to do the in-between part. So I have negative 5 to positive 3, and then I have positive 3 to infinity. Okay? Okay. Number 9 is similar to what we did in class today. It's 2 minus x is greater than or equal to 0. We subtract 2 from both sides. Negative x is greater than or equal to negative 2. When we divide by negative 1, what do we have to do? Flip the sign. Okay? So it's x is less than or equal to 2. Have a good day. Okay? And then you don't have to graph it, but when you do graph it, it's helpful. Okay? Because we start here at negative infinity, and we go to positive 2. And that's our domain for that one. And that's the one that we did in class today. We did that problem, or one similar to that one in class. The circle problem, I think everybody did pretty well on that in class for the circle problem. A lot of times I would say, draw a picture, draw a picture, draw a picture. And so basically what we have here is we have a circle, and the diameter of the circle has negative 6, 5, and 4, 5. Okay? So the first thing that I kind of encourage students to do, the midpoint is going to be the center of that circle. So you're going to use the midpoint formula to find the center of the circle. So I have -6 plus 4 divided by 2. And then I have 5 plus 5 divided by 2. Okay? So -6 plus 4 is -2, and -2 divided by 2 is -1. 5 plus 5 is 10, divided by 2 is 5. So my midpoint, or the center of my circle, is -1, 5. So that's how I find the center of my circle. Okay, and then students are like, well, okay, I've got the center of my circle. Now what do I do? Okay, how do I find my radius? Well, your radius is just a length right here. And do we have a formula that helps us determine the length of a line segment? And we do. It is the square root, and I'm going to take my x values. So I have -1 minus 4, and I'm going to square those. Then I'm going to take my y values, which is 5 minus 5, and I'm going to square that. So -1 minus 4 is -5, and we're going to square it. 5 minus 5 is 0. So I end up with the square root of 25, which is 5. So then if we put this in our circle formula, so we've got y minus h squared plus y minus k squared. How about x? How about x right here? Does that make everybody happier? X minus h squared plus y minus k squared equals r squared. So we're going to have x minus -1 plus y minus 5 equals 5 squared. And your final answer, x plus 1 squared, y minus 5 squared equals 25.
For the radius, can you just, like, if you actually, like, graphed it, can you just count?
Yes.
And then square